Hello and welcome to today's lesson on the national grid. Our learning objectives are to describe what the national grid is, explain why the national grid is an efficient way of transferring energy, describe how transformers are used in the national grid, and calculate using potential difference and current for transformers. Electricity pylons are quite a common sight across the UK. They're used to transmit electricity from power stations to homes and businesses. But why do they have to be so high up? Well, the answer is obviously because they're so high voltage, and because of that voltage they would be very dangerous if they were close to the ground. Electricity in the UK is sent from power stations to homes, schools and factories by a vast series of wires and cables called the national grid. The national grid is composed of power stations, transformers and transmission lines. I'd like you to now pause the video and make a quick sketch of the picture that you see in front of you before we move on. One of the problems with transmitting electricity is that as electricity passes through wires, it produces heat, and that heat is wasted energy. In order to minimise that wasted energy, we increase the voltage and reduce the current. This makes the process more efficient and reduces the loss due to heating. Transformers are used to increase the voltage of electricity before it is transmitted, and shortly before it is transmitted into homes, they are used again to reduce the voltage. Step-up transformers increase the voltage, step-down transformers lower it back down again. It's important to remember that the energy transferred depends on both the voltage and the current. By increasing the voltage, we decrease the current, so the total energy remains the same. Now we'll describe how you can build a transformer, starting with a soft iron core. We then wrap a coil of wire around one side of the iron core. This will be known as the primary coil. We then wrap another coil of wire around the other side of the soft iron core, and this is the secondary coil. We're now going to look in a little bit more detail on how this works. We start by introducing alternating current into the primary coil. This then produces a magnetic field around the coil. The changing magnetic field is carried by the soft iron core, which creates a changing magnetic field around the secondary coil, which in turn produces alternating current. A step-up transformer will have a higher number of loops on the secondary coil. If we have twice as many loops on the secondary coil as we do on the primary coil, then we will have twice the voltage coming out of the secondary coil as we put into the primary coil. Here we have twice as many loops on the secondary coil, so 10 volts is increased to 20 volts. In a step-down transformer, the voltage is reduced. There are more loops on the primary coil than the secondary coil. Here we have half as many loops on the secondary coil, so the voltage halves from 10 volts to 5 volts. Sometimes voltage will be given in kilovolts. 1 kilovolt equals 1000 volts. I'd like you now to briefly describe in your books what the national grid is. Pause the video while you write a couple of lines to explain its function. In your answer, you may have described it as a network of transformers, power stations and power lines that supply electricity around the UK. Once again, in your books, I'd like you to describe what a step-up transformer does. Pause the video now while you answer the question. A step-up transformer will increase the potential difference or voltage. And again, in your books, please explain why step-up and step-down transformers are used in the national grid. Step-up transformers reduce the energy loss dissipated by power lines, and step-down transformers reduce the potential difference so it's safer for consumers. And finally, I'd like you to explain why the national grid is needed. Once again, pause the video while you answer. Here we have a possible answer. Please pause the video while you go through your own answer and compare it to this answer. Add any additional detail to your own answer that may have been missed off in your first draft. We're going to now look at step-up and step-down transformers. We can use the transformer equation given here to calculate an unknown voltage. This is given to you in the exam and you're not expected to remember it. It is primary voltage divided by secondary voltage is equal to the number of turns on the primary coil divided by the number of turns on the secondary coil. Here we have a transformer with 1,000 turns on the primary coil and 3,000 turns on the secondary coil. 30 volts is applied across the primary coil. What will be the output? Well, if you substitute it into the equation, you can calculate that it would equal 90 volts. You could also solve this through ratios. Here are 3 more questions for you to work through. Again, do these in your book and pause the video while you're working through it before we go through the answers. And here we have the answers. So mark your own work, go through it, and if you've missed any of the detail from your question, please feel free to annotate it or add that detail in now. As our final activity for the lesson, I'd like you to copy this table and then complete it by adding the number of secondary turns and whether it is a step up or a step down transformer. Pause the video now while you do that, and then we'll go through the answers. And here we have the answers. Make sure you go through this and mark it. If you've made any mistakes, go through and make any corrections. Well, that brings us to the end of today's lesson on the national grid. I hope you found it interesting and learned a little bit about how the national grid works, its uses and its potential dangers. Thank you very much for listening.